Okay, here are the notes for 6-4 special parallelograms. So if you recall back in 6-1 here, quadrilaterals, parallelograms, underneath parallelograms there are rectangles, rhombuses, and squares. We're going to now focus in on the rectangles and rhombuses. We're almost going to assume we have a parallelogram where opposite sides are parallel, but now we're going to add the rectangle and rhombus to it. So this first box here is all about rhombuses. They have all the properties of a parallelogram. Opposite sides are equal. I'll just write this down. Opposite sides are equal. Well, first of all, they're parallel. Opposite sides are also equal. Opposite angles are equal. And diagonals bisect each other. These four dots here are pretty much all of the properties of a parallelogram. Now we're going to add some more ideas. Bisect each other. This is all from the previous sections about parallelograms. 6-2. Opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, and of course, opposite sides of a parallelogram are parallel. Now we're going to expand on rhombuses in the first box, and what makes them slightly more different than a parallelogram, and also rectangles. So with a rhombus, not only do the diagonals bisect each other, so when you draw them out, they will literally cut each other in halves, but each diagonal of a rhombus bisects the angles. So they don't just cut each other in halves, they bisect the angles. So in this picture, AC bisects BAD, so that angle 1 here is equal to angle 2. And they also wrote this same sentence, AC bisects this angle up here at the top, BCD, so that angle 3 is equal to angle 4. That's not always the case in a regular parallelogram. In a parallelogram, the angles don't get split at the corners. But with a rhombus, they do get split in the corners. The other major idea with a rhombus is the diagonals of a rhombus are perpendicular, which of course means 90 degrees. And right here, dead center, it's 90 degrees. Okay, that's for a rhombus. Now for a regular parallelogram, that's not 90 degrees if you look carefully, okay? So this is a special type of parallelogram, and that would be a rhombus. And in this picture, diagonal BD perpendicular to diagonal AC. Okay, for a rectangle, rectangle has all the properties of a parallelogram. Of course, opposite sides are equal, and they're parallel. Opposite angles are equal. In fact, they're all 90 degrees. And the diagonals would bisect each other. But there's one other thing about a rectangle. The diagonals are congruent. They actually have the same exact length. So in this picture, AC from one corner to the next is equal to BD. Now again, that's a rectangle where it's 90 degrees. Now a normal parallelogram, these diagonals are not equal. You can tell that this US looks longer than R to T. But when you turn everything to 90 degrees, then these diagonals make the exact same length, so they are congruent. All right, this next group here is essentially all of those three previous guys in reverse. It's basically saying, hey, I've got a parallelogram. How do I know if that parallelogram is a rhombus? So if you have a parallelogram, not just any four-sided figure, if you already know it's a parallelogram, and the diagonals bisect the angles. So if this diagonal here splits these angles equal, maybe 30 degrees, 30 degrees, 30 degrees, then this picture must be a rhombus. And this is basically theorem 6-9 in reverse. You know you have a rhombus, you bisect the angles. Well, you don't really know what you have. You have a parallelogram, but if you notice I'm cutting the angles in halves, then it must be a rhombus. Same with the 6-13, it's the opposite of 6-10. If you have a parallelogram and the diagonals are perpendicular, then this thing must be a rhombus. So if you go corner to corner here, and corner to corner here. And if you notice 90 degrees, well then this has to be a rhombus. Okay. And finally 6-4 is the opposite of 6-11 with rectangles. You got a parallelogram, you draw the diagonals, they happen to be congruent, then this parallelogram has to be a rectangle. So if I go corner to corner and that's 10 inches, and I go corner to corner here and that's 10 inches, well then this must be a rectangle. Okay? Alrighty, finally just one problem here that we're going to do. Find the measurement of each angle here. So there's angle 1, angle 2, angle 3, angle 4. Now the key with this is a rhombus. Certain things are true with a rhombus. First of all, the diagonals of a rhombus right here are perpendicular. Right in the middle is 90 degrees. So in this picture here, this is a rhombus, which it is from the given. That's 90 degrees, so angle 1 is 90 degrees. By the way, all of them are 90 degrees here. Okay. This diagonal cuts this in half. It's 50 here, it's 50 here. Opposite angles of a parallelogram are equal, and a rhombus is a parallelogram. So this is 50 and this is 50. So angle 2 is 50. Angle 3 is 50. The diagonals of a rhombus will split those corner angles in half, 50-50. Now number 4 is not 50. Do not assume everything's split in half. Let's go ahead and deal with this one triangle here in yellow. All triangles add up to 180. So basically I'm going to take 180 degrees minus that 90 minus the 50, and you get 40 degrees. So this is 40 degrees, this would be 40 degrees, this would be 40 degrees, and this would be 40 degrees. Okay, and this was 50 degrees. All right, and there you go.